Hello, Legacy students. So today we're going to look at graphing a quadratic equation. What you're going to want to have on you, your notes, you're going to want a calculator today and then a pen or a pencil. So basically, what is a quadratic equation? A quadratic equation, or a quadratic function for that matter, is a function that can be written in the form y equals ax squared plus bx plus c, where a is not equal to 0. This form is called a standard form of a quadratic function. So that's basically how it's always going to look. Ax squared plus bx plus c. Sometimes our b can be 0 and sometimes our c can be 0 as well. So now, your graph is normally going to be a U-shaped, and this is called a parabola. So that's the actual name for that kind of graph. So if you notice, I have this U shape right here. It looks like a U, right? That is the parabola that we have. You can fold each parabola so that it matches exactly the two sides. This is called symmetry. You guys have seen symmetry in life before. The human body, they say, is actually symmetric. The fold of the line that divides the two parabola into two matching halves is called the axis of symmetry. So, if I would draw my axis of symmetry, notice how it's like right here, right? Cuts it perfectly in half. Now, this is going to be a line into an equation. You can actually make the equation of an axis of symmetry. So that's going to be x equals, notice how it's cutting through the x-axis, equals the number it cuts through. So it cuts through 1. So that would be my axis of symmetry, the equation of that axis of symmetry. Now, parts of a parabola that you kind of want to know about. The vertex, that is the middle of the parabola. This vertex would be right here. See how it's like the bottom point? Now, this is the middle of the parabola, like I said. But one other thing that's kind of cool about it is you can actually find it when you don't have a graph. So this is found by taking negative b over 2a to find the x. So negative b over 2a is going to get us the vertex, the x value of our vertex. Once you find the x value, then you just take it and you plug it back into the equation to find your y. It's pretty simple, actually. Now, a minimum or a maximum. They're pretty much what you think they are. A minimum, kind of like minimum wage, is the lowest point. A maximum would be the highest point, kind of like the peak. Now, each parabola will not have a minimum and a maximum. It will only have a minimum or a maximum. For example, this parabola right here, he opens up. Notice how it's opening up. So this one opens up. So is this right here a minimum or a maximum? Is it the highest point or the lowest point? The lowest point, right? So this is a minimum, and its minimum is y equals 2. See how it's 2? It's where it hits. Y equals 2 would be your minimum value. So let's actually try a few examples of this. So notice how we have all these different things that we can ask about a parabola. But first, what we need to do is graph it. We first need to get this graphed. So you're going to find your vertex first. So we're going to go negative b over 2a, right? So our a is 2. Notice how we don't have a b. And then a c is 3. So no b means there's 0. So I'm going to have 0 over 2 times 2, which is just 0, right? So my vertex starts at 0. What happens when you plug 0 into the equation? That's going to give us our y. So I'm going to go 2 times 0 squared plus 3. Well, 0 squared is 0, times 2, 0, plus 3, 3, right? So this is my vertex. That's going to go in the middle of my table so I can graph. Now let's pick some numbers around that. -1, -2, 1, and 2. So now, if I plug -2 in, you're going to want to plug -2 into there. So it's going to be 2 to the negative times -2 squared plus 3. That's actually 11. Let's check the next one. 2 to the -1 squared plus 3. -1 squared is 1 times 2. 2 plus 3, 5. And then that's a 5, and that's an 11 also, if you'd plug it in. Notice how these are the same values. That always will happen with a parabola. It's kind of nice about it, actually. So let's graph those. -2, 11 is going to be about right there. -1, 5, it's going to be right there. 0, 3, 1, 5, and 2, 11. That goes about right there. So if I graph my parabola here, there we go. Alright, so my axis of symmetry. So if I draw my axis of symmetry in here, where does it cut through? It cuts through at x equals, remember it's always x equals 0, right? That's where it is. Notice how your axis of symmetry matches the x value of your vertex. That always, always, always will happen. It's pretty awesome that it does. Now, does this open up or down? What kind of parabola? Is this going upwards or downwards? It's going up, right? So it's going to open up. Now, do I have a minimum or a maximum? I have a min, right? And my min is y equals the lowest value on my parabola in the y values is 3. So y equals 3. Now, here we get to something called domain and range. Now, you may remember domain and you may remember range from a long time ago. Domain is your x values and your range is your y values. So, the question I need to ask myself, what x values does my graph cover? That is what domain is telling us. What x value does the x's cover? So if I look here, notice how this is going to keep growing bigger and bigger and bigger, right? And on this side as well. When it's like that, that means that I'm going to get all the x's. Well, I need to write some way to say I get all of the x's. So I'm going to say x equals all reals. AKA, I can write it like this. It's an R, 2 lines, and then you're going to draw an R on it. That means all reals. That's just a shorthand way of writing all reals. It's because I can cover all the negative x's, 0, and all the positive x's. Now, my range. I need to figure out the range. What do I cover all my y's? That's the first question I'm going to ask myself. Doesn't look like it, right? I'm not covering all these y's. Nothing on my graph is on here. What about, do I have any numbers above that? I'm covering all the numbers greater than a number, right? So y needs to be greater than or equal to, and then what value is the starting point? I'm starting at 3. That would be my range. Notice how my min value is the same number and is the same value as my table. Notice how that happens. That actually always happens. It's pretty cool that it does. So let's try the last example here. This should be actually example dos. So first things first, find your vertex. So A, B, and C. So negative B over 2A. Negative B, negative 6. That's a positive 6, right? So 6 over 2 times A. A is 1. So 6 times 2 times 1, that's 6 over 2. My x value is 3. Now, what is my y value? So let's take that 3 and let's plug it in for x. 3 squared minus 6 times 3 plus 4. 9 minus 18 plus 4. That's -5 once you did the math there. Alright, so that's going to be my middle of my graph there. So I need to pick some numbers bigger and smaller than 3. That would be 1 and 2 and 4 and 5, right? Now, if you plug it in, do a double check, make sure my math makes sense. But I got -1, -4, and then -4 and -1. Should work out. I did my double checking when I was plugging them in, so be careful. Always kind of check my work here too. 1, -1, let's graph those points here. 1, -1, 2, -4, 3, -5, 4, -4, and 5, -1. Wonderful parabola. So now, my axis of symmetry, whoa, can't draw. Right there, right? And that is what x value? That's 3. So my axis of symmetry, x equals 3. I'm opening up again, right? Which means I have a minimum. Y equals, what's the lowest y value I'm covering? -5, right? Now, all my x values, so I'm going to have x equals all real numbers. Notice how it's all reals for both of them. That actually is going to be common for all values of the parabola for your domain. That domain on any quadratic is always all reals. Now, what about our range, you're saying? Well, my range, y is, am I bigger? What number am I starting at? I'm starting at -5, right? Am I bigger than -5 or smaller than -5? Bigger, right? I'm getting to the bigger y values. So y needs to be greater than or equal to -5. And that is how to find the domain and range. That's kind of the biggest different thing that we're doing today. And that's the end of this video. See you later, Savers.